very proud to have you, ma'am.
Thank you.
Okay, we will wait for another 5 minutes, ma'am. We have nearly 200 plus participants. Let them join and then we'll start, ma'am.
Okay.
Okay, we have Dr. Balaji, Professor, Computer Science Department, Panima Engineering College, to welcome you, ma'am.
Good
Okay.
afternoon, ma'am. Good afternoon, ma'am.
Yeah, good afternoon, Balaji. How are you doing?
Yeah, we are good, ma'am. We are good.
So today is the last day of your FDP program.
Yes, ma'am. Yes, today is the
ma'am,
last day.
yes.
I think this is the last session, or
No. We have 2 more sessions, ma'am. We have 2 more sessions. Experts joining from South Korea and CIT Coimbatore. So after this session, you have 2 more sessions.
Okay.
Okay.
Thank you.
Yeah, we will wait, ma'am. We will wait. We will inform you, ma'am. Once it started, we will inform you.
Yeah.
Okay, thank you. Balaji, recording start பண்ணிட்டீங்களா? Balaji? Balaji, sir?
Yes, I have done. I have started.
Okay. Recording started. Okay.
Satish sir, I think we can start.
How
sir.
many participants joined, sir?
Around 60. Around 60 have joined.
Okay. Let us start, Balaji sir.
Okay.
Ma'am, shall we start, ma'am? Are you ready, ma'am?
Yes, I'm ready.
Okay, ma'am.
Yes.
Thank you, ma'am. Thank you.
Okay.
Balaji sir, see that recording is started.
Yeah, sure.
Thank you.
Okay. Right. On behalf of Department of Computer Science and Engineering, it is my distinct honor to welcome our speaker for this today's session, Dr. Himani Saini. She is a senior scientist at UR Rao Satellite Center, URSC, Indian Space Research Organization, Bangalore. She received her MS in Industrial Mathematics and Informatics and PhD in Operations Research from Indian Institute of Technology, Roorkee. Her career in space science research and mathematical program spans over a decade. Initially, few years she has worked on launch vehicle programs. Currently being a mission expert, she is responsible for mission design, mission analysis, mission planning, and missions operations for low Earth orbit satellites. She is an operation director and mission director for various Indian remote sensing satellite and scientific missions. She has been involved in many programs of ISRO for communication needs, social obligations, and scientific missions to meet the national requirements in the areas like remote sensing, meteorology, and interplanetary exploration. She is the recipient of ISRO Award for her major contributions and excellence. Till today, she has contributed in 30 Indian remote sensing satellites and 4 scientific missions. She has played major role on Chandrayaan-2, 3 Exposat mission. She is among the motivating leader to pursue the extra miles. She is also an IEEE senior member in 2023. She was the candidate for MTTS ATCOM member for Region 8 and 10. Currently, she is serving as a member of Women in Microwave Subcommittee under MGA with the MTTS ATCOM. She was IEEE Computer Science Liaison for Women in Engineering in 2024. She is serving in several leadership roles such as Vice Chair, Secretary of IEEE SAP 7019 Working Group, IEEE WIE Industry Expert Network, and much more. As a IEEE Proactive Volunteer, contributing under her capacity in various scientific domains, she is a member for many professional bodies. She has a good amount of publications in her credit in peer-reviewed journals and international conferences. She is an ardent nature lover and works for its preservation. Now you can take over the session, ma'am. It's over to you, ma'am.
Thank you so much for a nice introduction, Balaji. My screen is visible now.
Yes, ma'am.
Yes, ma'am. Yes.
Yeah, first of all, thank you so much for inviting me and for this nice introduction again. So, as I'm working in the URO Satellite Center, that is one of the lead center of the ISRO in Bangalore, Karnataka. And my center, URSC, URO Satellite Center, is the forefront of the satellite technology towards conceptualization, design, fabrication, testing, launch, and in-orbit operations of a spacecraft. So as I came from the satellite center, so therefore I choose to talk about the satellite journey. And hence today I'm going to attempt this talk to provide a glimpse of the application satellite technology in India and how it's got involved and necessity to sustain the Indian viewpoint through the socio-economic purposes and experiments the operational space services are the part of my today's talk. Actually, this theme of this FDP is aligned with the quantum computation. That is not my core field, but later, after the talking about the overall spacecraft mission analysis, I will be highlights about the quantum mission which ISRO is going to float in the near futures. So these are the content of my today's presentation. These are about this I'm going to speak about today. So The world changed on 4th October 1957 when the Soviet Union launched the first artificial satellite. And the satellite was 85 kg satellite. It lies as a shape of the basketball, and its weight was, it's like 53 centimeter diameter, which has been launched. This satellite worked for 92 days, and after the 92 days of the survival, gravity took over and the satellite burnt into the atmosphere. Then after 1957, 1958, the first satellite, that is Explorer 1, that was the American first satellite, which was launched. Afterwards, in 1960, India, our visionary Dr. Vikram Sarabhai has laid down the foundation of the Indian space program. And afterwards, the journey took on towards this. Is there anything I'm able to hear some background voice?
Yes,
Can
Balaji
anybody
sir,
mute?
I think some participants, please mute your mic. Participants, please mute your mic because it is a disturbance for the speaker. Please. Balaji sir, can you please note down? Balaji?
Yeah, I'm checking out.
Okay, okay. Participants, please mute your mic. Done, Balaji?
Okay, I will be continuing
Yes,
now.
done.
Thank you, ma'am. Thank you.
So that was
Sorry.
in 1960, India has laid down the foundation of the Indian space program, and our first satellite, that is Aryabhatta, was launched in 1975 and continued with Bhaskara 1 and Bhaskara 2, Rohini. And Apple was our first measure in the effort of the area of the communication satellites. Remote sensing also gained experience those time. So meaning is that the stress in those days in establishing the basic capability and the infrastructure development in the field of launch vehicles, satellites.
I'm sorry to disturb you, ma'am. I'm sorry to disturb. Ma'am, can you put it in presentation mode, ma'am? I'm
It's
still,
not
it is
in
in slide.
presentation mode. Yeah.
No. It is still in slide mode.
Now it's in presentation mode.
No, not yet, ma'am. Yes, ma'am. Now it is perfect. Thank you.
Yes, now come.
Yeah. Thank you. So the space application has finally arrived in a great shape as per the today's scenario. So India has made significant progress in the last 6 decades in the development of the space technology systems and their applications, with the successful launch of Indian remote sensing series of the satellite, onboard Polar Satellite Launch Vehicle, and the recent launch of the GSAT onboard Geosynchronous Satellite Launch Vehicle, GSLV. Indian Space Research Organization has achieved self-reliance in orbiting spacecraft for Earth observation, communication, and scientific experiments. So this is a journey of our Indian space program, and we have realized so many satellites in these areas. So now I'm coming to the space system. So what is space? Space is a zone that occurs 100 kilometers above the planet, where there is no appreciable air to breathe or to scatter a light. But in India, if we talk about space, means Indian Space Research Organization. So satellite technology and its usage is very important. So space technology is the technology that is related to entering or retrieving objects or life forms from space. So everywhere technology such that weather forecasting, remote sensing, GPS system, satellite televisions, some long distance communication systems critically rely on space infrastructures. So now I would like to talk about space exploration objectives. Why it is needed? Why we should explore? There are more practical reasons for space exploration, but one of the principal reason we must continue is that we are all explorers. That's why human number in the billions from our earliest upright steps. So we have endeavored to learn more about the world around us, and this allowed us to build civilization. So exploring space is opportunity not only to discover new world and build advanced technologies, but to work together towards a larger goal, irrespective of the nationality, race, or gender. So there are so many comets and asteroids. Don't care for us. So there are uncountable big asteroids and comets out that could smack into the planet and ruin your day. It happened in several times back in past also. It's not if another larger asteroid hits Earth, but when? So all these reasons makes us we should explore. The space exploration plays a very important role, and the new technologies and research. Human didn't involve to go into this space, but we go there anyway. I would like to talk about the space system. When we talk about the space system is a very complex system. A complex system, as defined by system engineering, is a set of diversely, intricately interrelated components working together towards a common objective. Space system is an engineering system of multidisciplinary systems which are linked and interconnected and influence each other. Now, I would like to talk about some challenges. Some satellite monitor signs of climate change, such as melting ice and rising waters. But there are so many other challenges also we came across because there is an absence of the atmosphere. We are having the weaker gravitational and the magnetic field, hostile charged particle radiation effect, and geostationary satellites have to survive through the geomagnetic storm, electron flux, thermal extremes. When we launch the satellite into the space, the satellite has to experience extreme cold and extreme heat, like minus 150 degrees centigrade to the plus 150 degrees centigrade. And during launch, spacecraft have to endure harsh environment like depressurization, acceleration, vibration, and acoustic loads. And there are different kind of satellites we call low Earth orbit satellite, geostationary satellites. For them, eclipse is also one of the challenges. To work in such a hostile space environment, remote operations, sophisticated design tool for design, analysis, and evaluation. There are so many more challenges involved to design any mission. So I'm going to give in this slide, I'm going to give the overview. And in my subsequent slides, I will be explaining all the phases and how we are developing these phases. That also I'm going to talk about in my upcoming slides. So here, when we talk about the space system design flowchart, what it involved? It involved a definition of a particular satellite mission to achieve the required application, time frame, requirements, and goal, and the challenges to design per requirements and achieve the target and goal in the stipulated time frame. If I talk about like broad functional level, we can divide the mission objective into the 3 categories, like phase A, phase B, phase C. Phase A is nothing but we call it as a mission planning. Phase B is a mission analysis, and phase C is a mission operations. In a phase A, what we do, we drive all the inputs from the mission objective. Based upon the project specific mission requirements, all the mission analysis has been carried out to arrive at mission configurations. Now, what is the output of the phase A that goes as input to the phase B? So what we do once we have arrived the mission configuration, so this drive mission configuration goes as input for this phase, and we design telemetry, telecommand database, we write flight control procedures. Flight control procedures is how to operate a particular subsystem. That is a step-by-step procedure to operate a particular subsystem. We design the CRP contingency recovery procedures in case of any anomaly happen. As per we have planned something, but sometimes the things doesn't go as per our planning. If such kind of scenarios will happen, the how to handle that. For that, we also prepare the backup we called as a contingency recovery procedures, and like sequence of event like that, we prepare all the procedures on the based upon the whatever the configuration we have arrived in the phase A. After getting the clearance from all the subsystem, we go for the final phase or the committee which clears all these procedures. After that clearance, what we do, we translate our planning into the operations. So my phase C is nothing but the final step. That is we do the planning of all the mission operations. So in this phase, what we do, all the initial phase operations like bus operations, payload operations are carried out to arrive at the normal phase operations. So this is the overall complete cycle I have told. I'm going to explain this in my further slides. So now I will divide whatever I told into the segments. So when we talk about the space system segments, it consists of the transport segment, it consists of the space segment, and it consists of the ground segment. So when we are making any satellite, so in order to launch that satellite, we required one launch vehicle. We required one transport segment. Transport segment is nothing but the launch vehicle we required in order to launch the satellite into the designated orbit. So we are having different kind of launch vehicle, PSLV, Polar Satellite Launch Vehicle, GSLV, GSLV Mark III. We are having. Now I'm coming to the space segment.
Participants, please mute your mic. Ma'am, please mute your mic, ma'am. Balaji, remove பண்ணுங்க Balaji, please.
And the space segment of the satellite system consists of the orbiting satellites and the ground satellite control facilities necessary to keep the satellite operational. And now the last segment, that is the ground segment. The ground segment, or we also call is the Earth segment of the satellite system, consists of the transmit and the receive Earth station and the associated equipment to interface with the user networks. So if I talk about the overall architecture of any mission, so it consists of the spacecraft, platform, payload. Payload is nothing but the camera, the orbit, the launch vehicle, the mission operations, the ground segment, user segment, and the broad mission operational phases. We call initial phase, we call launch phase, or target orbit acquisition phase, and so on. Depends upon the type of mission as well. But the pre-launch operation, normal phase operations, these are the part of each and every operations. As I told, these are the typical mission elements. Now I would like to talk about the types of the satellite mission. So we are having different kind of satellite mission. Earth observation satellite, we call the IRS series. We are having the communication and meteorology satellites. And we are having the third category is the scientific missions like Chandrayaan 1, Chandrayaan 2, Mars mission. Now upcoming mission is MOM 2 is going to come very soon. And the Venus mission, like in the years, the world's first mission, India is going into the explore the Venus planet as well. So we are having 2027 the Venus exploration mission as well. And we are having the satellite navigation program as well, like as GPS. Our ISRO is also making our own navigation system, which we call as a NAVIC. But the NAVIC is for just for the Indian regions and its nearby boundaries. And also for disaster management support, also we are having the Earth observation and communication satellite systems together provide a space-based disaster system support. So these are the different various kind of missions are there. Remote sensing satellites, communication satellites, scientific missions, navigation, and the experimental. So I will be talking about this slide in my upcoming presentations. So now I want to talk about the orbits. So we are having low Earth orbit, we are having medium Earth orbit, we are having geostationary orbit, we are having the Volney orbit. So when we talk about the low Earth orbit, the low Earth orbits are the placed in from 500 kilometer altitude to 1500 kilometer altitude range. When we talk about the medium Earth orbit, are placed from 8,000 kilometer to 18,000 kilometer range, and the geostationary orbits are placed 60,000 kilometers and above. Molniya orbit, those are some special kind of orbits. It's all depends upon the type of mission, the type of application. On the basis of that, we select the orbit. So now I have to design any mission. To what to start, like as I told in my previous slide, we have to drive the configuration. So in order to drive that mission configuration, so we have to do a lot of mission analysis. So we have to select the orbit. In which orbit we should place the satellite? In what altitude we should place the satellite? At what inclination? It's a what type of mission is there? So many factors are involved in order to choose the satellite orbit. So as per the mission requirements, we do the analysis and we arrive at the orbit selection. Also, as per the requirement, we also see when any proposal comes, any project comes, what is the feasibility? Does that mission is feasible in order to achieve the required application? For that also we are doing the study and analysis. We target orbit acquisition strategies, because whatever the orbit we have proposed is required for this mission. How to achieve that? For that also we have to analyze a lot, because if you see like for the low Earth orbit, when we are launching the satellite, we launch the satellite and within hours and minutes, the satellite will get placed into the designated orbit. But let me talk about the science mission, like Chandrayaan kind of mission. Those are not like that. And we ISRO are not having such kind of launch vehicle which can place the satellite into in one go. It takes lot of time. We cannot go in one go. So we go step by step to reach to acquire the designated orbit. For that, if you have seen, like for Chandrayaan kind of mission, we do so many burn and we arrive at the orbit. It takes few days. It will not happen in a same day. What are the delta V? What are the propellant budget? What is the propellant required? So all those things we have to study. And what are the size of the propellant tank? Launch vehicle selection. So such we have to select such that the spacecraft operational life should be maximum and the cost should be the minimum. That way we have to select. So we are ISRO are having different kind of the launch vehicles, and each launch vehicle are having the uh, different capacity. We are having the GSLV Mark III, which we call it has the capacity to launch the spacecraft of the 4 ton. So till today we have developed that, and for this Chandrayaan, for such kind of mission, we have used our that we used to call as Bahubali. We have utilized that launch vehicle to launch our satellite. So generation of the normal mission profile, simulation, mission scenario, from separation from launch vehicle up to the target orbit acquisition and the payload commissioning. We have to study of the Sun Earth spacecraft geometry and the definition of the spacecraft orientation in each mission space. So what happened when we launch? Let me talk about some low Earth orbit. When we launch the satellite, the satellite has to, let me give the example of the one of my mission, that is the ExpoSat mission. In that mission, we are seeing the star. So when we have launching the satellite into the orbit, so we will be the for low Earth orbit on an average, the orbital period is 90 minutes, and in a day, the satellite will be having 14 to 15 minutes. So what happened when the satellite is revolving in the orbit? It will follow some attitude. So like we require sun pointing attitude to generate the power. We also go for like earth pointing attitude to download the data, and sometimes we required like star pointing attitude to see the star. I'm giving the example of one of the mission like ExpoSat. So my spacecraft was following operated in 3 geometries: sun pointing geometry, earth pointing geometry, and the star pointing geometry. Sun pointing geometry to generate the power, earth pointing geometry we are coming by rotating the spacecraft to download the data, and we were in star pointing geometry by in order to see the stars. And like that, we have to arrive the attitude definition as per the requirement of the missions. The normal orbit phase, attitude sensor, calibration phase, orbit maneuver phase, and the payload operation phase. We do all those things. The launch orbit parameters and the launch window requirement are also provided to the launcher agencies. Sensor selection, like we use star sensor, uh, for all the how to get the attitude of the spacecraft. For that we use the different sensors like earth sensor, star sensor, in order to compute the attitude of the spacecraft. So generation of the following data over the mission profile as an input for the subsystem designs, thruster configuration to meet the attitude and orbit control requirement. See what happened when we launch the satellite. I'm giving an example. We have decided, okay, my satellite I have to launch in 500 kilometer altitude, and it should go at 95.03 degree inclination. So whenever my launch vehicle places this satellite into the orbit, it will not exactly launch it to the 500 kilometer altitude and 95.03 degree inclination. It will be plus minus. It will be either over or it will be under. So it will be around 500. It can be 510, it can be 505, it can be 498. Like that it will happen. So once we place the launch vehicle has placed the satellite into the orbit, then we correct the orbit of the satellite. So in order to correct the orbit of the satellite, we use the thrusters. So now I'm coming to the space segment. The spacecraft elements can be broadly categorized into the two classes. One is the mainframe, one is a payload. Mainframe we also call the bus subsystem, or other is the payload. These are the two categories for each and every satellite we used to follow. So space segment equipment carried on board the satellite under two functional areas, bus and the payload, and each typical satellite configuration consists of these two. When we talk about the mainframe, or we call it a bus, refers to the basic satellite structure itself and the subsystem that support the satellite. Now let me talk about the bus subsystems are mechanical and electrical. When I talk about the mechanical and electrical, the physical structure, the power subsystems, and the attitude in the orbit control subsystem, thermal control system, and the command and telemetry subsystems, all these comes as a part of the mechanical and mechanical. If I talk about the electrical subsystems, the power, we require power, we require for communication, attitude and orbit control, telemetry tracking and command system, and data handling. So overall, if I say the mainframe system is required to maintain the satellite health, its orientation, and its position in the orbit. For this, we require the mainframe. Now I'm coming to the payload, the second part. The payload on the satellite is equipment which provides the services, or we say payload is the main configuration driver of the spacecraft. The payload is the instrument which fulfills the mission objectives of the spacecraft. So now for a different kind of mission, we are having the different kind of payloads. Like we are having the communication satellite. So if I say it's a communication satellite, payload consists of the transponders for and they consist of the antenna subsystems. If I talk about the civilian, that comes under the Earth observation, the navigation payload for the constellations such as the GPS and search and rescue payloads. And another, the scientific mission, those contain the instrument mainly aimed for the space explorations like optical UV gamma ray telescope, interferometers, spectrometers, rovers, robotic instruments for manned and for the sample return mission, like our upcoming Chandrayaan 4 and Chandrayaan 5 we call as a LUPEX mission. So we will be going to the moon and we will be bringing the sample from there. So these comes under the category of the scientific mission. The manned mission, that is the Gaganyaan mission, which is the another journey. Now we are in this phase, and very soon the already 2 demonstration flights has happened. The one demonstration flight is going to happen in the month of December or the January, that is TV22. And slowly, once we will be confident in our demonstration, then we will be going with the manned flight as well. For that also, you have seen the 4 astronaut has been prepared, and 1 astronaut has already gone and visited the Shubhanshu Shukla and has come back. For the other space agencies, he has gone. So depends upon the type of mission, type of the requirement, as per the application, we are selecting the payloads. Now I would like to talk about the spacecraft element design criteria. So configuration evolved considering the various requirement. Let me mass. So we have to see the mass also. So we are having different class that we call a different class. If we say if my mass of the satellite is 1 to 10 kg, then we call it as a nanosatellite, which requires 10 watt of power. If my mass of the satellite is 10 kg to 100 kg, we call microsatellites. If my mass of the satellite is 100 kg to 500 kg, we call small satellites. And the satellites whose mass is 400 kg and above, like 4 ton, 5 ton, we call as a large satellites. Those requires a high amount of power, that is makes more than 1 kilowatt. So we have to see the mass of the spacecraft and the sufficient power to load the mainframe as well as the payload operations. Now, thermal for good conductance and less dissipation, because as I told, when the spacecraft is rotating into the orbit, it is going through the extreme cold environment, it is going through the extreme hot environment. Material and component, the mechanical, it should be small, reliable, and robust design. And whenever we are launching any satellite, sometimes some satellites are the heritage of the previous satellites, or it's a new satellite. So like that, we have to see all these factors. And whenever we are making the satellite, we would like to have the mission life should be maximum. So mostly, normally the mission life is the 5 year. We would like to have the more mission life for whenever we are designing any satellite. And same time, we have to look for the budget and schedule as well. It should be within our limits. And finally, the technology which we are going to demonstrate, going to use, is feasible or not. So these are the spacecraft element design criteria. That's why I told space system is very, very highly complex. It's not easy. Now, I have just talked about the mainframe, which I talk about the bus. Now I want to talk about the payload. Payload, you can understand like is a camera. So payload design drivers. How to decide the payload for any mission? It depends upon the type of the requirement and what kind of objective we would like to achieve from that. So payloads are chosen based upon the requirement and the project definitions. If the satellite is communication spacecraft, then payloads will be the transponders or antenna. And if the satellite is the civilian, then we have to look into it the camera, what it contains, what is its swath. Swath is the area seen by the satellite. When satellite is revolving into the orbit, then the camera is seeing the certain portion on the surface of the earth. So that area which the seen by the camera is called the swath. What is the resolution? What are the type of images? What are the attitude required and constraint? The lightning condition, FOV restrictions, energy generation. So like that, so many factors are there which we have to look into it. Like I talk about the resolution. There are 4 types of resolution: the spectral resolution, spatial resolution, temporal resolution, radiometric resolution. So all those things are involved in that. So based upon the project specific requirement, we are driving on those factors. This, as I have told you, to spacecraft, once everything is done, then we have to look for the spacecraft design verification. So like this is a structured model, then we do satellite FEM, we do this is the stalled model, this is a deployed model. So before deployment, how it looks like that, and after deployment, how it looks like that. So we do all this thermal, these kind of all the phases. And this is the envelope. This envelope, you can see, this is nothing but the launch vehicle. So inside the launch vehicle, at the upper stage, our satellite will be kept like that. So we have to go through all these phases, and we do the testing and all for this. Now, as I have talked about the structure design, I have talked about the testing. Now, I would like to talk about the reliability, quality management. That is also very important for our system. So when we talk about the reliability quality management system, our Earth spacecraft has to go through a PDTC cycle, the product, design, testing, and the calibration in order to make zero defect systems is the quality policy of the ISRO. So many of the electronics and the mechanical components that are used in the satellites are known to have the limited lifetimes, or the what we say the finite probability of the failure. If the failure of one of these component, then the mission to reduce the communication capacity of the satellite or the backup of the redundant until will provided. So we should have the redundancy. If one system, we have to design the spacecraft in such a way. If we should have the backup, if one system, main system failed, so redundant should take over so that the mission can continue. So design of the system must be such that when one unit fails, the backup can be automatically take over or to be switched into the operations by a command from the ground. So that way we design. And later on, it goes through these phases. Now, I would like to talk about the future remote sensing satellites and the frontiers. The major thrust area of the remote sensing program are on launch on the demand and to provide the continuity of services in the land mass, water resources, oceanography, atmospheric series, cartography, large scale mapping, etc., and microwave imaging. So these are the new technologies, high resolution imaging payloads, hyperspectral imaging, and multispectral imaging payloads, onboard automation, highly stable and agile profile, high data rates and carbon data transmission systems, high data compression ratio and encryption systems, advanced modular data handling and storage system, detector development, and many more. Here, few I have highlighted. If I talk about the communication satellite, to present demonstrate satellite communication is dominated by the fixed satellite services and direct to home services. Further service growth areas are internet, multimedia and personal communication services, direct to home high definition TV series, bandwidth on demand services, e-governance and the strategic communications, many more, and the communication payload configuration, drive engines, KU band. Now we are in the upcoming satellites, we are going to use the KU band with DTH, with national beams. Like that, in our upcoming satellite, we will be using that Ka band, which has been already being utilized. This is there. Now the space-based application using AI and machine learning. Yeah, we do. The spacecraft anomaly detection. If anything will happen in the spacecraft, see when the satellite is on ground, we can do. When the satellite is in the space, how to detect and how to analyze and how to correct. It's very challenging. So spacecraft anomaly detection and its correction. For that, we use this AI and machine learning. Drift rate computation using the machine learning. So what happened when we launch the satellite into a designated orbit? It will not always retain into, like suppose I have launched a satellite in 500 kilometer and so inclination. It will not always remain that. What will happen? So many perturbation forces are acting on the satellite, which will pull the satellite, and the Earth gravity, it will try to pull the satellite down. So it is 500. So we have some certain band. The up to this limit, the satellite will be there in the orbit. When it is crossing that, so we are correcting. So the satellite will be drifting. So what we will do, we will correct the orbit so that it will remain in our designated band. So like the space debris detection and mitigation, for such kind of things, we are using AI and machine learning. Now, as I would like to touch upon the Opto Quantum Communication Program of ISRO. That is, we call it Shakti mission. Anybody is there? Can we speak? I'm feeling like I'm only speaking. Satish, are you there? Balaji?
Yes, ma'am.
Yes, ma'am, we are hearing.
Yeah, thank you. So now I would like to talk about the ISRO program. I will not go into much detail because of the internal reasons we cannot everything we can't tell publicly, but I will tell what ISRO is looking into it and how we are utilizing this quantum theory. So there is one mission we call Shakti mission. So that is the Opto Quantum Communication Program. So like I have told na ki what is the before deciding any missions, we have to go through so many analysis, need, requirement. So after that, only after doing the analysis, feasibility and all, we drive at the mission configuration, as all those things I have explained in my previous slide. So what happened here, the quantum communication, the background and the need aspect, the increasing demand for the security enabled communication or antidote to quantum computing threats. Terrestrial QKD network are limited to the shorter distances. I'm not going more depth of this QKD and all. I think previous 5 days, the participants have already having some fundamental and already they have enhanced their knowledge on that. So I'm not going deeper to that. And the satellite-based free space QKD link can provide services to the ground station over thousands of kilometers and integrated satellite ground QKD network. So quantum cryptography and QKD, so based upon the laws of the quantum physics, it provides the unconditionally secure way of distributing cryptographic keys and thereby communication. We are going to implement that, but in my, it's not like that. Whatever the satellite we are launching, we are already having the, whenever we send any command to the satellite, we also doing the encryption and decryption. Those theories implementation is already there. Now the optimal communication background is like the need aspect for that is like 100 seconds of Gbps over optical link, low power and lighter terminals as compared to RF, and tight security, intra-satellite link and the LEO constellation, interplanetary communication, low latency, LEO constellations, etc. So our Shakti mission objective here is the satellite-based the quantum communication. So QKD between satellite and the ground stations and the quantum secure data downlink, and the inter-satellite QKD technologies through encrypted optimal link in the LEO satellites. And the satellite-based optical communication. So here, with that, actually, we are going to demonstrate a high data rate optical communication bi-directional link from a low Earth orbit satellite to the ground and ground to the low Earth orbit satellites. Demonstration of high data rate optical communication, inter-satellite link, LEO to LEO, low Earth orbit satellite to the another low Earth orbit satellite. And establishment of the ground station for optical and the quantum communication. So we are not having the that many stations. So we are having the few stations like at SAC Ahmedabad, and few are going. We have location has been finalized where we are going to establish these stations as per the requirement of this project. So here, the main objective of the Shakti mission to launch 2 satellites with optimal quantum communication technology payload for development and demonstration of the satellite-based quantum communication and the satellite-based optical communication. That's why we call this mission as an opto-quantum program with the optical ground stations, which I told we are going to establish many more, and demonstration of high data rate with the optical communication inter-satellite link between the LEO and inter-satellite QKD technologies through the encrypted optical links, and the establishment of the new ground stations, augmentation of the existing ground stations, etc. So these are the major highlights I would like to tell about the Shakti mission. So we are having we will be using 2 low Earth orbit satellites for this to demonstrate this, and we will be having the payload we call opto quantum. This will be utilized, and we will be having the circular orbit, like 500 kilometer altitude, and we are having the inclined orbit. So like that, if I say how we have decided the altitude, this is 5 kilometer, 560, 400, 600. So we have to do so much analysis. What inclination should be there? It should be the polar orbit, sun synchronous, non-sun synchronous, inclined. So like that, we have to, as per the requirement of the mission, we have to do the analysis. We have to study and we have to arrive that. So for this, we will be using the launch vehicle. We are going to do like single stage launch vehicle. To 2 SSLV will be utilized, and this is very highly expensive projects. And this will happen soon in the upcoming years. So this is the integrated satellite and terrestrial QGD network. So with that, I would like to conclude my today's presentation. So this is the future satellite program perspectives. And with that, I would like to end my today's talk. And I hope you have overall structure, how to design a mission, how to analyze and how to operate the particular satellite, and what are the phases has been involved. All those things I have covered. The complete cycle of any mission I have covered. I hope you have get and enlightened with this talk. Thank you.
Thank you, ma'am, for the wonderful presentation. Participants, if you have any queries, you can ask to ma'am.
Thank you, ma'am. I have 2 questions. It's a simple. The first one is, what is the material used to construct satellite? Same material for all the systems or combination of that? I believe strong strength and lightweight material has to be used, but what type of material used are different type of material. The second question is, you have mentioned the 2 systems are there, main satellite as well as a backing up satellite. One is the main satellites are failed, the backup will be taking automatically. How the changeover taking place? Either it is by software side or a relay systems, something like that, it will be there. Or another thing is, and any time in the past, have you experienced both the system failed? If so, how it was recovered? Thank you.
Okay. Let me tell you the kind of material we are utilizing to make the satellite. Is a lightweight material, like we use like we call like aluminum alloy. So that is lightweight, strong, and commonly used for the main structure, like skeleton, the body of the body. Inside all the packages, all the subsystem will be placed inside that. And one is for the titanium.
Okay.
Also we use like for high strength and component that needed to endure extreme stress. As I told now, like spacecraft has to go through very, very harsh environment. And the carbon
Yes,
fiber,
ma'am.
composite, and the honeycomb structure panel. So, and for thermal protection, we use like multi-layer insulation MLIs, and the thermal blankets we utilize, and the radiators we utilize is there. And if we talk about the solar panel, we use silicon solar cells, gallium arsenide cells, protective glass. Like as per the time, so many technologies are coming, new things are coming, we are utilizing. So let me give you an example of one of my satellite, like nano satellite. I am handling as a mission director for. I'm for that project. So what we happen, like we have to minimize the weight of the satellite. So we have to look into that also. But it doesn't mean
Yes,
not only the weight. It should be able to sustain in the thermal environment as well. That
thermal,
we
yes.
also have to. And not only that, when we, I told this is a mechanical structure. The body is there, skeleton. Inside that, so many subsystem will be there. So like one onboard computer, one OBC card is there. Over that, some battery is there. So when we are placing
Yeah.
all these things inside, you just imagine inside the box. So what will happen? The thermal dissipation should not be there. So what will not happen? The energy transfer of the one package to the other, it should not harm other. So you have to, in the small compact space, you have to put all the packages on. So that should not be, the interference should not be there between one package to the another package. That also we have to take care. Like, but
Yes,
same
ma'am.
time
In the
we have to look
computer,
in,
in the
we have to look, we have to look into
in
the
the
mass as well. So as per the requirement, as per the type of the satellite, as per the type of the mission, is a nano satellite, I call a 1 to 10 kg class. So accordingly we will be selecting and we are going ahead. Now your second question, you were saying something, Kumar Swami?
yes, ma'am. In the computer, the CPU is getting heated up. To cover up, I think the heat sink material will be placed over the central processor unit. Like that, when the thermal is there any absorption or resistance put on the metal or coverage?
I told you that we use MLI, we use a thermal blanket. We are having these kind of things are there. We are covering the packages with that so that the insulation
Okay.
will not happen.
Okay, ma'am. Okay.
So like that, if you have seen any demonstration model, you see now some golden kind of sheet is there. It is placed. So that is for this to cover the thermal MLI and all those things only. Like those are some gold sheets, pure gold
Okay.
sheets. Like that, some material has been utilized and placed over that. Now I would like to come to your second question. Like you are telling how we are coming to
Change
the
over.
like
Yes.
what happened see, whenever we design any satellite or anything, so that has two chain. One is the main chain, one is the redundant chain.
Yes.
So we do either the whole, like for each thing, power has two chain, main and redundant chain. Everything is having the main and redundant, main and redundant, main and redundant for each and everything. So
Oh,
what happen
okay.
if any of the chain fails? So we switch over to the other chain. Let me tell you, like give me one example of the, like we are having some redundancy, like battery voltage main and battery voltage redundant, like two sources are there. So voltage also play a very important role. So due to some malfunctioning, something has happened and we are not getting the sufficient thing, something, or we have seen the one strike due to the high amount of the power in the some profile. So we switched from the main to the redundant. So then at that time, after switching, the satellite will be working finely, but we will look into the cause, what was the issues in the main system, why this has happened. Then let me tell you, then we analyze, and sometimes system get extreme, got failed also. Let me give the example of the nano satellite. In the INS-2B was the nano satellite. In that, like we used to have the 4 reaction wheel, which provide the momentum and torque to the space in order to generate the momentum and torque of the spacecraft. How the satellite will be moving, so it's like the wheel and inertia will be, and all those things, wheel and inertia will decide the, for that, how the satellite will be moving fast and slow. So what happened, 4 reaction wheel were used, were there. One wheel got failed. So in order to get the things, at least minimum 3 wheels are required. One wheel got failed because some ball bearing issue has happened. Wheel got stuck and we tried from ground by giving the commanding. We are not able to recover. Then we have gone from 4 RW mode to the 3 RW mode. So in 3
Okay.
RW mode also the satellite work, but minimum 3 wheels are required. We have placed 4, 3 are required, but
And both the
if one
system, the
more wheel
data will
fails,
be
if the
updated
one more
online,
wheel
right?
fails, then the mission got failure, because we are not we will not be there. That has happened, but that has happened at the end of the life. When the end of the life, we this has happened in one of the nano satellite. So most of the things, it has not happened, like the mission got failure and all those things. We always design the system, we always as per our human capability and thinking, we design a satellite, and all the permutation combination we apply, we look for what are the best substitute, what are the backup for that system we plan. And whenever any failure happen, we try to analyze, and sometimes we are able to we are able to diagnose and we are able to correct. But sometimes system failure has happened. Some package has failed in the spacecraft. Now we can't do. Nobody can go from the Earth to the space and correct the package. Whatever happened is happened. But in the absence of that, how the satellite can work, that we try. And sometimes, like I given you the example of the wheel failure, in such case there is no we will not get anything, because you cannot control the attitude of the spacecraft, how the momentum will get generated and all those things. So such kind of scenarios has happened and we look into it. So we design in such a way we always have the backup for all those things.
Thank you very much, ma'am.
Thank you. Any other question?
Participants, do you have any other questions?
Ma'am,
Yes.
you said about the QKD and all. Is that in your center, in research center, do we have any opportunities to come and learn regarding that QKD, how it works, or how to design?
ISRO is not having such kind of facility ki you can come and learn, but there are someone remote IIRS, Indian Remote Sensing Satellites, is there, Dehradun. So sometime there are so many 15 days and 20 days structured training programs are there. That program contain different kind of structure. Like today I've given, like talked about the whole mission life cycle, like that, like QKD, like that, like different center. I think SAC Ahmedabad is having such kind of program and course. When they declare, those are the paid courses. So whenever such kind of courses comes, and it will be available on the space center website only. So once those get such kind of courses are coming, you can apply. There will be very limited seats, and you can join those courses, and you can enhance your knowledge. That way it happen. But sometimes it's not always for the public, it is for only scientists as well, or sometimes it's for public or student as well. All kind of programs are there, you have to look into it. But coming to inside ISRO and getting the demonstration and all such kind of things are not there. But yeah, courses and lecture series, such kind of programs are there.
How do we get that courses are available in website, or it is daily running notice will be there?
So whenever such courses will be coming, at least 60 days before it start getting advertised in ISRO headquarters. One is the ISRO website is there. So there the things will be keep floating, that you have to keep your eye, madam. Because whenever it is coming 2 months before, it will keep floating, and you have to apply the application. And shortlisting also happens. If your profile gets shortlisted, then only you will get the opportunity to attend that course. It's not like whoever is applying, everybody will get. That is also not the scenario. That you have to look into the website, ma'am, always. So many courses will be keep coming nowadays. And one more thing is there for the faculties. Since it's a FDV program, I would like to tell, there is a one program, that is a response basket. What is the response basket is there? Whatever the challenges, like whatever the requirements of there as per the new technology, so many problems are there in that book, response booklet. So you can, if you go through this response basket, so many problems will be there. You can choose the problem as per your area, as per interest, as per your expertise, and you can make the proposal and submit to the headquarter. So, and you will get, once if you will get the shortlisted, you will be called for the presentation. Meaning is that if you are able to solve that problem, so definitely you will be called. It will be going to help to the system only, from that perspective only. And sometimes you can come up with this such problem. You have to apply, like your like university level, you have to apply and you have to submit, and this is the demand, very high demand problem, and how to solve that. If you come out really a very good solution, which is really going to help the organization. So definitely that proposal will be taken, and you will get the opportunity to work with ISRO scientists. That way also this has happened. So now so many programs are also there. Response Basket is there. So many academia industry programs are also launched by the previous chairman, I think 2024 onwards. Now so many programs are there where the academia also can come in front and participate and contribute for the Indian space program as well.
Thank you. Thank you, ma'am. Participants,
Yeah.
do you have any other doubts? Oh, ma'am, I think there is no doubts, ma'am.
Okay.
You want something to say, madam? Anything to say to participants?
I just want to say, I hope the participants have enjoyed the session, and if anybody has any query, they can reach out to me and they can ask their queries. I can drop my email to the Satish. They can send their queries to me there. So whenever I will see, I will get time, I will definitely try to help and try to answer. And one more thing I would like to tell regarding the internship, like for to guide the student, because so many, because of this now past 2-3 years, because of the science mission, so much fascination has come, like people, students wants to work for this space sector. So they want to do the internship in the ISRO. So all the centers will get twice in a year, they will open up for the internship program. So at that time, the window will get open only for 1 week. Let me tell you, for our URAO satellite center, it get open in the October 1st week. I think 1st October, the 7th October, it get open. So that time student need to apply. If the student gets selected, they will get the opportunity to work for the internship program in the ISRO, and one will get open in the month of the March. For the March, when they will apply, they will get opportunity in the month of June and July. That is hardly 45 days internship they will get. So, and this is URAO Satellite Center, but the other space center also having the internship program. So you can tell your students, they can apply, and if they get selected, so they will get opportunity to do the internship in the ISRO various centers. This is the information only I would like to pass. And thank you so much. Yeah.
Can you repeat the dates, ma'am? When
Usually for URAO Satellite Center, the internship program opens twice in a year. One in the month of the October 1st week, I do remember, September and October 1st week, and one open in the month of February, March. I think March only, March 1st week. So, but that window get open for very limited time, 1 week time only. In that 7 days, only student need to apply, because thousands of application ISRO receives, and hardly 15 to 20 people will get selected. Earlier, this was not a scenario. Usually, only ISRO scientists, children's used to get the opportunity. But now the scenario is not like that. Outsider, any students, anybody can apply if they really had a good profile, so they will get opportunity to work in ISRO, do the internship.
Okay.
Any other question? Yeah.
Okay. Okay, ma'am. I think that's the final question.
Yeah.
Thank you so much, ma'am. Thank you so much for giving us your valuable session. And despite of your busy schedule, you given us a session. Thank you so much, ma'am. Very proud to have you. And thanks for giving us insights on how the ISRO projects, what are the projects that has been done in ISRO. And also we came to know about Gaganyaan projects and the Shakti quantum related project. And also you have shared the information about the internship that is happening in ISRO. So that will definitely help the students community as well. So these are all the takeaways that we have took from your session, madam. Thank you so much again, the participants and the resource person, Dr. Himani, madam.
Yeah. Thank you so much again, the organizers and all the participants. Thank you.
Thank you, ma'am.
So with that,
Participants and next session. Yes, ma'am. Please, ma'am.
we can
You want-
conclude. Yeah.
Yes, ma'am. Yes, ma'am. We can conclude, ma'am.
Yeah.
Thank you. Thank you. The participants in next session will start from 3:30 p.m. So we'll see you again in another 10 minutes. Thank you. Thank you, ma'am.
Thank you.
Sir, can we log out and log in again? Get out and get in?
Yeah, you can, sir. You can join in the same link, sir. No problem at all. If at all, if you don't have any problem again signing in, until then there won't be any problem.
Thank you, sir.
Okay.